Hello students, welcome to Dronacharya online classes. I am your Swami sir. Today I am going to discuss a new chapter, that is electrochemistry. So before starting this video, so if you are watching my video for the first time, so please subscribe and share to your friends and tap the bell icon for more updates. Okay, now let us start the session. So now, before going to this electrochemistry, so one thing I want to discuss about, that is redox reactions. Okay, so here, so first of all, we are going to discuss what are redox reactions. So here, redox reactions. So why we need to study these redox reactions in electrochemistry? So here in the electrochemistry, we can observe that in many cases we can observe redox reactions. So here, what are redox reactions? So these are the chemical reactions in which both oxidation and reduction takes place simultaneously. So here, redox reactions are those reactions in which oxidation and reduction takes place simultaneously. Now here I am using the two terms. So one is oxidation. So here oxidation, and another term, that is reduction. So generally this oxidation and reduction can be defined as, so here, so we can define this oxidation. It is the addition of oxygen. For example, if you take aluminium, so if you add oxygen to this one, so we get aluminium Al2O3. Okay, so here we are adding oxygen to this aluminium metal, so we get Al2O3. So here there will be addition of oxygen takes place, so it is a oxidation reaction. Now here reduction means a removal of oxygen. So if you add carbon to this aluminium oxide, so we get aluminium and CO2 gas. So here oxygen will be having more affinity towards the carbon when compared to aluminium. So that's why here we get CO2 gas. Okay, so here we are removing the oxygen from the aluminium. So it is a reduction reaction. Now another way to define the oxidation and reduction, that is a removal of hydrogen. So here removal of hydrogen is nothing but oxidation. For example, if you heat this CH4, that is methane, in the presence of oxygen, we get CO2 and H2O. So here these hydrogens are removed from the carbon, so it will be converted into CO2. So here we are removing the hydrogens from this CH4. So it is a oxidation reaction. Now reduction means addition of hydrogen. So addition of hydrogen is nothing but reduction. Let us consider alkene. So CH2 double bond CH2. Okay, so it is a ethylene. So here ethylene in the presence of palladium, so it is a hydrogenation reaction. So here we are adding H2 to this ethylene. Okay, so we get alkane, that is ethane. So here we are adding hydrogen to this alkene, so it is a reduction reaction. Okay, so here we know these two kinds of definitions in the earlier one. Now in this electrochemistry, So we are using another two definitions to define this oxidation and reduction. So here, so that is removal of electrons. So here a removal of electrons is also called as oxidation. Okay, so for example, I have a sodium metal. So if I remove the one electron from this sodium metal, we get Na plus, and here it is the electron. So it will be converted into Na plus ion. So here this reaction what we call as oxidation. So here we are removing the one of the electron from the sodium atom. Okay, so addition of electron is nothing but reduction. So here let us consider a chlorine. Okay, so if you add one of the electron to this half Cl2, we get Cl minus. So here it will be converted into Cl minus after addition of this one electron. Okay, so here during removal of the electron, so the oxidation state of this sodium metal will be increases. So it means, so increment in increase in oxidation state or oxidation number is nothing but oxidation. Okay, so here decrement in oxidation state is nothing but reduction. So these two definitions generally we are using in this electrochemistry. Okay, so here removal of electron is nothing but oxidation. During removal of electron, there will be an increase in oxidation number or oxidation state. So here addition of electron. So here addition of electron is nothing but it is a reduction. So here during addition of electron, so there will be a decrease in oxidation state. Okay, so what is meant by oxidation state? So here, so the term oxidation state or oxidation number. Okay, so oxidation state or oxidation number. Okay, so here what is meant by oxidation state or oxidation number? So here oxidation state means charge on the any element, any element in its bonded state. So here, so oxidation state means, so charge on the any element in its bonded state. So here, so oxidation number can also defined as it is a number which denotes the either losing of electrons or gaining of electrons. So here oxidation number is a number which denotes the either losing of electrons or gaining of electrons. So let us consider a molecule that is AB. So here A is the one atom and B is the another atom which is bonded together. So there will be a formation of molecule. So it is a AB molecule. Okay. So here we can observe there are three cases in this molecule. So here first case is if the electronegativity of A is equal to electronegativity of B. So here, so there is no charge on the A and B because here this bonded electron does not move towards any atom because they are having same electronegativity. Okay, so here another case that is, so if electronegativity of A is greater than electronegativity of B. So here in this case, so this bonded electrons will move towards the A, atom A in the molecule. So here this A will get a negative charge and this B will get +1 charge, that is positive charge. Okay, so here, so more electron, due to the more electronegativity of this atom A, this bonded electrons move towards the atom A. So here this bonded electron pull towards A. So that's why this A will get the negative charge. Okay, so another case, that is if the electronegativity of A is less than electronegativity of B. So in this case, this bonded electrons will pull towards the atom B. So here this B will get the negative charge and A will get the positive charge. Okay, so here due to the electronegativity difference in between the two atoms in a bonded state, there will be so polarization of this bond will be takes place. So due to polarization of this bond, so there will be a existence of charge on the atom or element will be takes place in its bonded state. So here, so oxidation state means so charge on the any element in its bonded state due to its electronegativity. Okay, so electronegativity. Okay, so now how to calculate this oxidation state? So here, in order to calculate this oxidation state, so we have some rules. So here the rules for calculation of oxidation state. Okay, so rules for calculation of oxidation state. Let us see rule number 1. So first rule, that is oxidation state of any atom is 0. Okay, so if you consider a free atom, that is oxygen or hydrogen or Cl or aluminium, so these free atoms will be having oxidation state will be in 0. We have N2, H2, Cl2, okay, so O2, so these are also having oxidation state at 0. Okay, so here this is the first rule. So oxidation state of any atom is 0. So here, so these free atoms, that is oxygen, hydrogen, chlorine, aluminium, so like this. So here these free atoms will be having oxidation state 0, and these homonuclear diatomic molecules, so these homonuclear diatomic molecules also having oxidation state 0 because there is no electronegativity difference between these atoms. Okay, so here second rule. So let us see the rule number 2. Now if you consider group 1 elements, okay, so group 1 elements, so these group 1 elements always exhibit +1 oxidation state. So these group 1 elements always exhibit +1 oxidation state. For example, if you consider sodium, potassium, rubidium, cesium. Okay, so francium is a radioactive element, so we can ignore that one. So here if you consider sodium, so which is having atomic number 11, so here it gives Na plus ion by the removal of 1 electron. This Na plus ion will be having electronic configuration 1s2, 2s2, 2p6, so which is equal to the inert gas, that is neon. So that's why this electronic configuration will be more stable in Na plus ion. So that's why here So it can show only +1 oxidation state. Okay, so here after removal of one electron, it will be having only 10 electrons. So this electronic configuration, which is similar to inert gas configuration, so that's why it is a more stable. So here group 1 elements will exhibit only +1 oxidation state. Okay, now let us see rule number 3. So here rule number 3. So group 2 elements. So these group 2 elements will exhibit the oxidation state that is +2. So they can exhibit the +2 oxidation state. So here we have calcium, magnesium, barium, strontium. So these are the elements which belongs to, so here we have beryllium. So these elements belongs to this group 2 elements. So here if you consider magnesium, so it will be having atomic number 12. So after removal of 2 electrons, it will get Mg +2 electrons. So this in this Mg +2 we have 10 electrons. So here 1s2, 2s2, 2p6, which is similar to neon. Okay, so it is a more stable electronic configuration. So that's why it can exist in only Mg +2. Okay, so in its bonded state. Okay, so it can exhibit maximum oxidation state, that is +2. So here, so these group 2 elements will exhibit +2 oxidation state. Okay, so now another rule that is related to hydrogen. So this hydrogen will exhibit 2 kinds of oxidation states. So one is +1 oxidation state and another one is -1 oxidation state. So here in the case of +1 oxidation state, so this +1 oxidation state will exhibit with non-metals. Okay, so non-metals. So if you consider H2O, so if the hydrogen is bonded to the non-metals, so it can exhibit +1 oxidation state. So okay, so here we have hydrogen. This hydrogen will be having so +1 oxidation state. So here in the case of H2S or in the case of H2SO4 or in the case of HCl. Okay, so whatever maybe the compounds or molecules which are related to hydrogen with non-metals, they can show +1 oxidation state. So here hydrogen can also exhibit -1 oxidation state when it is bonded to the metals. So when it is bonded to the metals, it can show -1 oxidation state. So here we can observe metal hydrides. So NaH. So here Na plus H minus. So here CaH2. Okay, this kind of molecules. So this hydrogen will exhibit -1 oxidation state. Okay, so now let's move on to next rule, that is related to oxygen. So here rule number 5. So here oxygen. So this oxygen will exhibit so -2 to +2. So it can exhibit -2 to +2. Okay, so if you see H2O, so in this H2O, so each hydrogen will exhibit +1 oxidation state and this oxygen will exist as a -2. So in the case of KMnO4, so here also we have oxygen in -2. If you consider hydrogen peroxide, so in the case of peroxides, so here we have hydrogen, oxygen and hydrogen. So in this case each hydrogen will exhibit +1 oxidation state. So here each oxygen will exhibit -1. So it can exhibit -1 oxidation state in its peroxides. Okay, so it can exhibit -1 oxidation state. Oxygen, so with the fluorine, So OF2. Fluorine always exhibit oxidation number minus. This fluorine having highest electronegativity. Okay, so here, so each fluorine will have -1 oxidation state. So here this oxygen will be having +2. So here oxygen will be having +2 oxidation state. Okay, so if you consider O2F2, if you consider this O2F2, so here we have fluorine, here also we have fluorine. So here this fluorine will be having -1, this oxygen will be having +1. This is -1, this is +1. So here this oxidation state is +1 for oxygen. Okay, so each oxygen will exhibit +1 oxidation state. Okay, so now if you consider superoxide, okay, so if you consider superoxide, that is KO2. So here potassium always exhibit +1 oxidation state. So here it belongs to group 1 element. So in the case of oxygen, so here, so it can exist as a -1. So here O2 minus, it means each oxygen will exhibit 1/2 oxidation state. So in this way, so oxygen can exhibit, so here, so oxygen can, so here oxygen can exhibit, so here oxygen can exhibit -2 oxidation state as well as -1 oxidation state and +1 oxidation state and +2 oxidation state here, and here we have -1/2 oxidation state. Okay, so these kind of oxidation states that can be observed in the case of oxygen. So one more thing you should be notice that, so here in the case of hydrogen, so in the case of hydrogen, so this hydrogen will exhibit +1 oxidation state with all non-metals except boron. So here, so boron will be having, so if you observe BH3, for example diboron, so boron hydride, here in this case hydrogen will be having highest electronegativity than the boron. So here, so hydrogen can be exist in -1 oxidation state. So even though it is a non-metal, so it can exist, this hydrogen exists -1 oxidation state. Now let us calculate the oxidation number of manganese in potassium permanganate. So here we have to calculate the oxidation number of this manganese in potassium permanganate. So here this potassium will be having +1 oxidation state, and here we have manganese, that is assumed as X. So we have to find out this X. So here, so oxygen will be having -2 oxidation state. Okay, so the overall charge is 0. So here the overall charge is 0. So here X is equal to, so here, so we have, so 1 plus X minus 4 into -2, that is -8, is equal to 0. So X is equal to +7. So here this manganese will be having +7. So in this way, so we can calculate the oxidation number or oxidation state of any element by using these rules. Okay, so by following these rules, so we can calculate the oxidation number of any element. So this is about the redox reactions and oxidation and reduction, and how to calculate oxidation number. Please do not forget to subscribe my video and tap the bell icon and get more updates, and please like, share, subscribe. Thank you for watching. Have a nice day.